All right, so we're going to look at a few of these, and we are going to figure out what is happening. So first of all, we want to know what our parent function is. So everything that you see on the left, the question is, where is your x? Does it have an exponent? So if it's in parentheses, that kind of sort of doesn't completely affect what I'm asking. But if you'll notice, up here, it says that your parent function is x squared. So I would like to figure out what is happening to my parent function. So what's different? So if I look at A, part A says that I've got y equals x minus 3 squared. So I notice that the only thing different between my original function, which is y equals x squared, and this one is that I've got a minus 3. If that minus 3 was gone, then I would just have my x squared. So what does that minus 3 do? Well, first of all, addition subtraction is going to tell you it either moves up, down, or it moves left, right. This one is inside and it is attached directly to the x. So that tells you it is a left, right. The question is, which way do you go? So this one is actually going to move right 3 units. So remember that if you're moving to if you're doing a left, right, it goes opposite of what you think. So this one is right 3 units. So when you look at this one, you see that it is actually option D. Okay, so let's look at B. B says I have x squared minus 3. So B is y equals x squared minus 3. So my question is, what's different from my original function? And in this case, I've got this minus 3 hanging off on the end. It is not attached directly to the x. It is attached to an x squared. So that tells me it's an up-down. Okay, it's not attached directly to the x. It tells me it's an up-down. So, and I do exactly what it says. So this tells me I'm going to go down 3 units. So if I look at that, I've got a translation that is 3 units, 3 units down. Okay, he is 3 units down. And then what do I have next? I have, hang on. For part C, I've got y equals 3x squared. So I've got a coefficient. I do not see any addition subtraction whatsoever. I see a coefficient. And I notice that if that 3 was gone, I would have my x squared back. Okay, so what does that 3 tell you to do? That 3 tells you, since it's a coefficient and it's bigger than 1, it's a stretch. So you are stretching him vertically by a factor of 3. So that's going to be option B. And then what do I have? I've got for part D, hang on, let me erase all this stuff. Sorry, my cat is doing something in the background. If I'm looking at part D, then what I don't know. All right, so part D says, what do I have? Y equals x plus 3 squared. So I see addition, subtraction. That tells me it's either a left, right, or it's an up, down. So where is that plus 3? So that plus 3 is attached directly to the x. So that says x plus 3. So notice there's some type of grouping symbols involved. So I do opposite of what I think when it's a left, right. So that tells me I'm going to go left 3. And then finally, what's the last option? My last option is going to be, hang on. My last option is going to be, let's use blue, y equals x squared plus 3. So if I've got an x squared plus 3, first of all, notice that if that plus 3 was there, I would just have my parent function of x squared. Okay, so that plus 3, is that attached directly to the x? No, there's no grouping symbols. It is attached to an x squared, but not directly to an x. And so if you're looking for it to be directly to an x, you're going to have some grouping symbols involved. So this tells me to go up 3 units. If it's just hanging off on the end, then it's an up, down, and you do what it says. So that's going to be 3 units up. Okay? So now, X out of here. All right, what have we got? So you're going to match each equation in parts A through I with a sketch of its graph. So, I don't know what this means. The correct graph for x squared plus 3. First of all, what is my parent function? My parent function is x squared. How do I know? Because I'm looking for my variable. It's not any place special. It's just sitting there. And does he have an exponent? Yes, he does. It's a 2. So my parent function would be x squared. So it would look like this. But I've got a plus 3 hanging off on the end. So what does that plus 3 tell me to do? That plus 3 is not attached directly to an x. It's attached directly to the x squared. There's no grouping symbol, so that tells me to do an up-down, and it tells me to be literal. So I'm going to take that parabola, and I'm going to make it look like the green thing. Okay? So look like the green thing. So when I come back here, well, good heavens, what is this? I am looking for something that went up 3 units. So if I go look at part B, then part B hits directly at 3, because then it was just shifted up 3 units. So I know that he is B. Okay? So I am going to check that, and look at me be right. Okay, so the next one says x squared minus 3. So x squared minus 3, actually, hang on. Let me back this up. It might be easier to go this way. Okay, so if I do this one, and we're going to full screen snip, and we're going to go bigger. Okay, well, that's not how you go bigger. All right, I'm going to go bigger. All right, so that is what I'm going to deal with. That's just going to be easier. So what I'm going to do is I am going to identify what's happened to each one. Okay, so looking at A, I notice that it's still symmetric about the origin, and I notice it dropped down 3 units. So that's going to be an x squared minus 3. I already know that B was an x squared plus 3 because I already identified that it went up 3 units. So let's look at C. It looks like C went to the right 3 units. So remember, right, left means it needs to be in grouping symbols directly with x. Since it went right, I need to do opposite and say x minus 3. It's not x plus 3, it's x minus 3. And then that quantity is squared. What happened to D? D got flipped. Instead of opening upwards, it's opening downwards. So how do I flip something? I just slap a negative in front, and that flips it. Okay, so let's look at E. So I'm going to zoom out of here for a second, and I'm just going to look at E this way so you can see exactly what happened. So this is going to be one of these where did it get shrunk, or did it get compressed or stretched? So if I look here, can I get to my next point by moving in a 1-to-1 ratio? So I'm going to go up 1, right 1, and there's my point. So this has not been stretched or compressed. So that original 1, 1, in other words, if it was sitting here, then my next point would be at 1, 1. Okay? So I'm looking for that movement of 1 to 1 is what I'm looking for. Well, now I've moved this thing, so let's find out where it went. It was here, and then I went this way and this way. So where did it go? It's not flipped, it's not stretched or compressed, but I did move it to the left 3 units. And so I've got my x plus 3 squared, and then I went up 4 units. So that's going to be the equation of that one. Okay, so now I have what is going on with F. So F, it can be bigger, hang on. So F looks like this. And now this is something that I want to look at more closely. So it didn't get moved. It's still anchored at the origin. But when I start looking, okay, you're irritating me. When I start looking at how close hang on. Sorry, I got distracted. All right, so it didn't get moved. I'm still at 0, 0. Okay, so here's my 0, 0. It didn't get flipped. So I'm not looking for any addition, subtraction because it's still anchored at the origin. And it didn't get flipped because it's still opening upwards, which means my only other option is instead of hitting at 1, 1, let's look and see where it moved to. It's hitting at 1, 3 instead of 1, 1. So how do I move from a 1 to a 3? I multiply by 3. So what that looks like is a 3x squared. So your coefficient is a 3 because you grew this from a 1 to a 3. So you multiply by 3. Okay, so let's look at G. How did I get G? G has still got a 1-to-1 ratio. So I still have this starting point, and I still move up and down and it's still a 1-to-1 ratio, okay? So to get to the next pretty point, I would still go either up or down 1 and then over 1. So I do know it has not been stretched or compressed. I do know it has not been flipped. I also know it's still anchored on the x-axis, which means it only moved left-right. It did not go up-down. So I know now that this thing moved to the left, so it's x plus 3 squared. Okay, x plus 3 squared. And then finally on the last couple, what do I have here? Well, now he's moved. So instead of being right here, where he would be at the origin, his vertex has moved. So I want to know, is he stretched or compressed? So how do I get to the next pretty point? It's a ratio of 1-to-1. So I moved up 1, right 1. So it's a ratio of 1-to-1. How did I get where I'm going? I moved right 3 and up 4. Right 3 and up 4. So there's no coefficient. It didn't get flipped, so I don't have to worry about negatives, but I did move right left and I did move up down. So I moved right 3 units. So remember, go opposite. And then I went up 4. So your number inside with the x tells you left, right, and the number hanging off on the end tells you up, down. And then finally, for the last one, what we have is, okay. So what I have for the last one is, how do I get from here to here? So looking at this, hang on. So, oh, good heavens. Okay, so it was anchored at 0, 0. So he was at 0, 0, but now he moved to here. So my first question is, did he get stretched or compressed? So I've got a 1-to-1 ratio. He did not get stretched or compressed. So I just need to worry about where he went. So if I'm here, if I'm right here, then that means I went left 3, down 4. So what happened? He didn't get flipped, so there's no negatives. He didn't get stretched or compressed, so there's no coefficient. But he did move to the left 3, and then he went down 4. So that's the equation that you're looking for. All right, so let's try. I'm not going to keep doing that. Yes, I want to leave. Okay. So on this one, it's going to be the same thing. Let me just talk about your parent function for a second. What is your parent function? Your parent function is going to be, where's your variable? Well, my variable is inside of brackets. What kind of brackets? Absolute value. So your parent function is y equals the absolute value of x, which looks like a v. So on that first one, it says the absolute value of x minus 7. You've got grouping symbols. So addition, subtraction tells you either up, down, or it tells you left, right. If it's inside the grouping symbols with an x, that tells you left, right. And this one you go opposite, so I'm actually going to go right 7 units. Okay, so then you can walk through the rest of those. So now I have, what does that say? All right, I want to graph the following function. So how am I going to do this? So using the graphing tool, I just need to know what's my parent function. So my parent function is, where's your variable? It's just sitting there, no place special. Does he have an exponent? Yes, he does. It's a 2. That is your parent function. What is different from the parent function to the function I was given? I have a 3. What does that 3 do? It's a vertical stretch. It's a vertical stretch of 3 units. So when I go to click and enlarge, notice that you've got 2 options. I've got a parabola, which is what the x squared is, or I've got an x cubed. Well, mine is x squared. And it says, click the graph to plot your curve. You can click anywhere, and it's going to plot your parent function. Now, all of a sudden down here, I've got some questions to answer. Is there a vertical stretch? Yes, there is. It's a 3. So watch what happens, sorry, to the original function. It's going to get taller and skinnier. So hit enter, and look, it gets taller and skinnier. So hit save, and there you go. And I'm not going to check it because I want to keep going. All right, so keep going. So now what do I have? Graph the following function. I would like to know what my parent function is. So what is my parent function? Where is your variable? Your variable is under a square root. Okay, that's important. So that tells me that my parent function looks like this. Well, now that says x plus 2. So what does the plus 2 do? The plus 2 is inside the grouping symbol, so it tells you left, right. So where are you going to go? You're going to go to the left 2 units. So that's what you're looking for. Okay, go to the left 2 units. And let me try and get a couple more done. So I'm going to graph this function. What is your parent function? Your parent function is, once again, where's your variable? It's underneath a radical. Does it have any exponents? Not other than the 1/2, no. So remember, I could rewrite that as x to the 1/2. So that's your parent function, which looks like this. So 2 things have happened. You've got a negative, and then you've got a 3. So what does the negative do? It flips it. So I've got my negative that's down this way. And then what does the 3 do? It stretches it. So it's going to be taller and skinnier. So that 3 is going to make him tall and skinny. So what you're looking for is something tall and skinny that got flipped. Okay? Tall and skinny and got flipped. So let's do a couple more. This is going to be just a little bit longer. All right, so I have this pretty little shape. Actually, that's a good place to stop because it's going to take a second. So I will see you in the next video. I forgot how to stop.